Okay, so now we're going to look at 1.3, experimental design. So the goal of every statistical study is to collect data and then use the data to make a decision. Any decision you make using the results of a statistical study is only as good as the process used to obtain the data. If the process is flawed, then the resulting decision is questionable. So we have 6 guidelines or steps of designing a statistical study. The first one is we want to identify the variables. Of interest and the population. So what do we want to know and who do we want to know it about? Next, we want to develop a detailed plan for collecting the data. And here we want to make sure the sample represents the data. Or sorry, represents the population. Okay, so if we were wanting to do a study about Basehor Linwood High School students, we wouldn't want to create a sample of just our male students because that's not a good representation of the whole population. We would maybe instead want to do a small chunk of students from every grade level. So that way we're getting a whole representation of everyone. So our third step, collect the data. And we'll talk about the different methods in which doing this here in a few seconds. Fourth one, we're going to describe the data. Using descriptive statistics. Statistics. I'm going to say techniques. If I can spell, maybe I will. Okay, pretend that says techniques. All right, we are going to talk primarily about this describing the data in chapter 2. Okay. We kind of briefly talked about inferential statistics in 1.2 or 1.1. So that kind of comes back in. So we're going to look at interpreting the data. And make decisions about the population using inferential statistics. And then lastly, we want to identify any possible errors or bias. Okay, so now a statistical study can usually be categorized as an observational study or an experiment. So an observational study is when a researcher observes and measures characteristics of interest of part of a population. but does not change. How about not change? Existing conditions. Okay, so we want to observe things just the way they are. So an example of an observational study would be if you stand outside the bathrooms in the math hallway and observe how many students wash their hands. You're not changing any conditions. You're just simply observing what's happening. So an experiment was when a researcher deliberately applies a treatment. Okay. So this is something that you can use a lot in science. So we have a control group, which is part of the population. With no treatment applied. Okay. Experimental units are the subjects in treatment, as well as the control groups. And then a placebo is a harmless, fake treatment that is made to look like the treatment. Usually a placebo is like a sugar pill, so it shouldn't change anything or alter the results. So if we want to distinguish between an observational study and an experiment, I want you to try these 3 examples, and then we'll talk about them in class on Monday. So now let's talk about our different methods of data collection. So there's several ways to collect data. It's all dependent on what the study is focusing on. So the first one we're going to look at is simulation, and this is the use of a mathematical or physical model to reproduce the conditions of a situation or process. Okay. Simulations are used primarily when we have situations that are impractical or costly to reproduce. It can also even be dangerous to reproduce as well. A survey is an investigation of one or more characteristics of a population. Usually surveys are carried out by people by asking questions via interview, internet, email, or phone. The most common survey and well-known survey is your census. Okay, remember we talked about this as being a survey of the entire population. Okay, so then we can look at experimental design. So in order to produce meaningful, unbiased results, experiments should be carefully designed and executed. It is important to know what steps should be taken to make the results of an experiment valid. 3 elements of a well-designed experiment are control, randomization, and replication. Because experimental results can be ruined by a variety of factors, being able to control these influential factors is important. One such factor is a confounding variable, which occurs when an experimenter cannot tell the difference between the effects of different factors. The placebo effect, this occurs when a subject reacts favorably to a placebo. Okay, so even though they're not receiving the treatment, they are acting as if they are. So that is more of a, if you're taking a pill that's the sugar pill, you're not actually receiving any type of medical treatment. Versus the Hawthorne effect, this occurs in an experiment. When subjects change their behavior simply because they're participating. So an example of this would be, say there's an experiment about like a diet pill, and you have a group that's receiving a sugar pill, and the person that's receiving the sugar pill starts actually losing weight. Okay. Hawthorne effect is when, say, you're doing your experiment on the diet pill, and you have subjects that are suddenly working out more or eating healthier simply because they're participating in this. Okay. So then that becomes a confounding variable because we don't know, are they showing weight loss because of the change of diet, because of the change in working out, or is it because of the pill? So those become complications within an experimental design. So also we have blinding, and this is where subjects do not know whether they're receiving the treatment or the placebo. Okay, this is how most experiments are done because you want it to stay unbiased. And then we have double blind experiment, and this is when neither the experimenter nor the subjects know if the subjects are receiving the treatment or the placebo. Okay, and this helps prevents bias. Okay. Okay, so another technique that can be used to obtain unbiased results is randomization. And this is when we randomly assign subjects to different treatment groups. Okay. Then we have a completely randomized design, and this is when subjects are assigned to different groups for treatment through random selection. Okay, so now we have blocks, and this is a way we group people. So this is when we group subjects with similar characteristics. Okay, so maybe we group based off of their age, or we group based off of their gender, or their grade level, or what classes they're taking. Okay. Then randomized block design is when the experimenter divides the subjects into blocks. Then within each block, randomly assign subjects to treatment groups. Okay, so took a picture from your book. So if we look at everybody, then we split them up by, here this example does age. And then we say, okay, some of you are going to receive the control or the placebo, and the other group of you is going to receive the treatment. Then matched pairs design is when subjects are paired. According to a similarity. Then one receives the treatment. And one receives the placebo. Okay, sample size is the number of subjects in a study. And this is really important, and we're going to be looking at sample size a lot throughout the year. Sample size, the smaller, the least amount of accuracy we have within an experiment. The larger sample we have, the closer we are to the population, so we can make a more defined inference about the sample. Another important part of experimental design is the sample size, which is what we just talked about. So to improve the validity of experimental results, replication is required. And this is the repetition of an experiment under the same conditions. Okay. And then the validity is the accuracy and reliability of the experimental results. Okay, so the next problem is we're looking at the different types of bias, or sorry, not bias, looking at which of those confounding variables can create issues. So if we just look at this first example together, the company identifies 10 adults who are heavy smokers. 5 of the subjects are given the new gum, and the other 5 subjects are given the placebo. After 2 months, the subjects are evaluated, and it is found that the 5 subjects using the new gum have quit smoking. So the issue here is the sample size. Is too small. Because we're only looking at 10 adults. Okay. So it's too small, so we're unable to validate the results. Okay, so a way to improve it is simply just increase the sample size. Okay. Another option is we could do replication. With another 10 adults. Okay. Now, again, since that sample size is small, you're more than likely going to get the same results, but can we validate that that's enough? So if you had to choose between the two, it'd be better to just increase the sample size. So that way you know you have enough information to say that it's true. Okay, I want you to try number 2 and number 3, and we'll talk about it in class. Okay, looking at sampling techniques. So first one with this we talk about is a biased sample. And this is when it's not represent of the population, or of the whole population. Okay. Census, we already talked about it being the survey of the entire population. So we're gonna skip that one. Talking about sampling, this is a count or measure of part of the population and is more commonly used in statistical studies. So then we have a sampling error, and this is the difference between the results of a sample in a population and we'll talk about this more in chapter 6. Okay, so one of our sampling techniques is a random sample, and this is one in which every member of the population has an equal chance of being selected. Okay. And then a simple random sample is when every sample of the same size has the same chance of being selected. Okay, so one way to collect a simple random number is to assign a different number to each member of the population, then use a random number table or a generator, or even like your graphing calculator. So we're going to talk about this example on Monday in class. All right, so last couple of ideas here. So there are several other commonly used sampling techniques. Each one has its advantages and disadvantages. So we have stratified sample, or sorry, simple random design, which we just talked about. And then stratified sample. This is when members of the population are divided into strata. That share a similar characteristic. This would be like age, gender, etc. So then a sample is chosen at random from each strata. Okay. So then a cluster sample is very similar. So this is when the population falls naturally into into subgroups. So an example of this would be like zip codes. Okay. Each with similar characteristics. Called clusters. So then we're going to select all members in one or more, but not all, of the clusters. Okay. And then systematic sample. This is when every member in the population is assigned a number ordered in some way a starting number is chosen and the members, and the members are selected at even intervals. Okay, and lastly, convenience sample. This consists, consists of members of the population that are easy to get to. Okay. And convenience sample, this is usually going to lead to bias. Okay, so I want you to try these 3 examples and then we will talk about them in class. I apologize for the long video. I hope you made it through it and I will see you guys next week.